ancestor of a binary tree. Given a binary tree, find the lowest common ancestor LC of two given nodes in the tree. According to the definition of LC on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T, thus both P and Q as descendants, where we allow a node to be a descendant of itself. So we have this example 3. We're given P and Q assigned as 5 and 1. 5 and 1 are P and Q. 5 and 1, and the lowest common ancestors of those is 3, so we have the output 3. And here, same 3 but different P and Qs, 5 and 4. So 5 and 4. 5 is the lowest common as ancestor, since 5 can be an ancestor of itself, and it also gets us this to 5 is an ancestor of 4. This one, example 3, is similar to this, where we have 1 and 2, but it's much simpler. We have only 1 and 2, so 1 can be a descendant of itself, and 2 is a descendant of 1, and it's 1 is the ancestor of both 1 and 2, so we get the output 1. So we can easily solve this with recursively with a DFS function. Recursively with DFS. Yeah, recursively DFS approach. So let's make our edge case, our base case. So if our root is non edge case, let's also add if root is equals to P, or root is equals to Q, return root. So if either of these functions are met, these conditions are met, then our solution problem will come to a stop. That's what a base case is. So let's define so for example here, if we're given this and either P or Q is 3, then our output will be a 3 without any calculation. So let's assign our left subtrees, right, subtree equals to self dot lowest common ancestor. I just copy and paste this lowest common ancestor, and then put our go to the left, so you can go to left subtrees, left, and then look for the P and Q, and it's the same for this too, but this time it will be for the right subtrees, right. So now if we have I'll copy and paste this. No, I'll just write down left sub3 and right sub3. So if we find P and Q in both left and right subtrees, if we find P and Q in either, if you find either P or Q in either, in both. No output. For example, we find both. We find PE in left sub3 and Q in right sub3. Return root. So if we find P and Q in either the left or the right subtrees, let's return our root. Else, if not, return the root of the left subtree is subtree or the right subtree. Whichever subtree has both P and Q. One for each subtree. Both one subtree has both, the other has none. So let's see if there are any syntax errors that need to be fixed. So if the root is none, really equals to, we automatically get a root. Return a root, find the lowest common ancestors of the two nodes in there. And then our left subtree is recursive on left search for our left on our P and Q will be assigned to our left subtree, and our right subtree is also the same for its right subtree. Oops, upload subtree. So if P and Q have roots have values in them and they're not none, return a root, whichever. Let's see if it is going to work. And it's been able to work. So now let's see if it's going to pass all cases. And it's been able to pass all cases. So let's see how let's look at the time and space complexities. Time operate, time and space, time complexity is O of H, size, no, sorry, of N, and being a node. each node will be visited until we find the BIOS P and Q. Size complexity of H being height in the parents 3, it will be O of log n in a scale. It will be O of n. And that's it for this problem. It's somewhat simple.